Worthington email because, now really, they don't actually care that much because they would have been the ones to make the money. If they control the email account, which they do, my WS Cloud email account, they control it. If I made money off YouTube, it is directly going to the owner of that channel, which is not me. It's actually Worthington. My name's on the channel, but I'm not the owner of the channel. Everybody should have graph paper out, but I see some people that don't. Everybody should have pencils out, but I see some people that don't. No, you have to have 1,000 subscribers before you can sign up to monetize. Alright, so if people are with me, and if the
following students are here, please come to the office for a moment. Ivan Ortiz, Morgan Harris,
this is slowing us down.
Caitlin Young, Bianca Morris, and Patrick Scully. Thank you.
These are probably kids that they're not 100% sure if they're here or not. If we can move at the pace that we should very quickly get through the 5 problems that we need to do together. 6 we're skipping, and 7 is your homework. So, blue sheets under your graph paper or under a binder somewhere that you're not working on them right now. Today we're grouping expressions, and I'm going to reset my smart board. Please? Thank you. So, the biggest thing about grouping expressions is expressions or equations. The only difference is an equation involves an equal sign somewhere. Expressions don't. But in an expression or an equation, there are almost always multiple terms happening because that's why it's an expression. That's why we've written it down. That's why we've shown a multiplication or shown an addition or something. Terms are separated by addition or subtraction. So I would like you to write that down on your paper because that's the easiest way that we can talk about terms. So we're going to say terms, not highlighter. Terms are separated. The vocab word, the term we're defining is terms. Separated, I think. Is that an A there?
Yeah, I don't know. Yeah.
I think it's A, like E-A-A. Separated by blank, addition or subtraction, but not multiplication division. If 2 things are multiplied together or 2 things are being divided by each other, they're a single term. So for example, 5 times 3 plus 4. This is term 1, or like a term, and this is a second term, term 2. There are only 2 terms, even though there's 3 numbers. 5 times 3 is 1 term together. That's the biggest thing people goof up in this chapter. That is the thing that I'm trying to teach very different than I used to. Terms are separated by addition or subtraction. So if we look at Cecil's move, his routine, right? Cecil, our slackliner, or tightrope walker, but that's kind of lame. Cecil's routine is 4, what's that little dot mean? Times, right? Multiplication. 4 times 2.5 plus 1. And Katrina wrote this out. Turn to your partner and discuss, do you think Katrina's diagram is right? And if not, draw down what you think it should be. So if this is our expression, so why don't you go ahead, actually write this expression on your paper. And if you want, you could do this instead of the multiplication dot. That is up to you. You can do that if you want. Is Katrina's diagram correct? If not, let's redraw a correct one on our paper. I'll give you probably 2 minutes to do this. Hint, Katrina needs your help.
Come on. You don't need all of them. They only need one. At the very end. Yeah, they need to get rid of those 3 ones. So it would be 2, 5, 5, 5.
I'll have a really cool story to tell you guys too once we finish our classwork that we need to get through.
So how was your marriage watching a marriage thingy?
What?
No.
That was last week. You're a week behind, Nick. I'm not answering that question because you're a week behind. So I'll go ahead and tell you, Katrina's diagram is wrong. You right now, on your paper, should be drawing a correct representation of 4 times 2.5 and 1. I was tutoring yesterday, making a huge emphasis on what we write mathematically is just a representation of what we speak. So what Cecil would actually say here to describe his routine is I'm going to do 4 moves of multiplication, right? Of 2.5. And then, addition, a move of 1. So Katrina did not draw this right because she drew 4 sets of 2.5 and 1. Right? We got a 1 here, 1 there, 1 there, 1 there. I heard a few people say we should only have 1, 1. Right? The 1 doesn't get multiplied by 4. Only the 2.5 does. So if you were to draw this out, my bet is you did 2.5. Now I get to cheat. You don't. Yeah. Fine, Nick. So my bet is you drew 4 moves of 2.5. Perfectly the same size, right? Because you can copy paste on your paper. Actually on graph paper, it wouldn't be that bad. And then 1 more move of 1. Now Cecil drew out this. Is he right? Is his diagram right? I guess I'll ask you a different question. Is this diagram wrong? Well, okay, hold on. Lily's saying technically, and I love when people say technically. What do you mean technically, Lily?
Because for addition, it doesn't really matter if you add it like before or after.
Ooh.
You're gonna get the same answer. But like if he wants to do it how the expression says it, then he should put the 1 at the end because the 1's at the end of the expression.
I like it. I dig it, Toby.
It's like it gets you the same expression. It gets you the same answer as you would get, but it's in the wrong order.
Gets us the same answer. Interesting. Eric?
You see, that could be interpreted in a couple different ways. It's right, whereas, like, sort of basically, like Toby said, you have the same numbers and pretty much the same problem, and you will basically, in the end, come to the same answer.
Yeah.
But it's wrong, whereas you've got it in the wrong order, so it's definitely not the right equation.
Yeah, so
It's right and wrong for different reasons.
Yeah, mathematically, he'll get the same thing, right, is what most of us have said. But technically, he put the 1 in the wrong place. If that matters, he's wrong. If it doesn't matter, then okay, sure, fine. Try this one. What do we get when we do these moves, and which one requires the longest span of slackline, or tightrope, if you want to say? Notice that these use the same numbers, but rearranged differently. So please write down the original, and then solve it. I will help you out with this. If we're doing multiplication, now this, you might need a calculator for. But up here, we're just doubling 6.48. So what's double the 6? 12. What's double 48? 96. So this is 8 plus 12.96, right, after we do that multiplication. 20.96, I believe. So then for B, one of your people at your team should have a calculator where you can like whisper that value around the room if you want. I see Callie's got a calculator, right? Callie, you want to be really nice and just tell us what 8 times 6.48 comes out to be?
8 times 6.48 is 51.84.
Thank you very much. While you're computing, I will tell you a weekend story. I was at Cedar Point on Saturday and history was made. The park reached capacity and they shut down the road going into it. So if you've ever been to Cedar Point, the causeway, it's kind of like a bridge, but it's not a bridge. The causeway going into the park that has 4 lanes, and normally they have like 3 going one direction and 1 going the other. They literally shut it down. Somebody else I spoke with up there, they spent 2 hours on the causeway in their car, just creeping across, trying to get into the park. So there were very long wait times. But to spin this back to math class, I was able to download the app and know the approximate wait times of rides because they do the math, right? They know how many people are in the line because how far back the turnstiles it goes, and they know how many people can go on each ride, and they do a math problem. Seriously, and they're pretty darn accurate. Like my buddy was like, an hour for Magnum, this doesn't look like an hour. I'm like, dude, somebody did math. They said an hour, I believe an hour, and it was an hour and 10 minutes.
You're like, I am a
Seriously, I occasionally throw around, I'm a mathematician. I am literally certified in math.
Everyone must be really disappointed in me, but I've been to Cedar Point since I was about like 4.
It's fun. Saturday was a disappointment. So if you want to be disappointed, I rode 3 roller coasters. Now, Hollow Weekends was still fun. What do I have to do first in C? Give me something I haven't talked with yet. Nick, I guess we haven't really talked. What do I do first in C? The addition, right? Because it's in the parentheses. So that becomes 10 times our 6.48. And I moved what was in parentheses, but it doesn't matter because all they're doing is showing us multiplication. And this becomes 64.8 because we know that we just shift the decimal when we multiply by tens. Or powers of 10, like 100, 1,000, 10,000, whatever. Now here, if we go back and reiterate the terms conversation, 8 is a term, and then 2 times 6.48 is a term. 2 is a term, and then 8 times 6.48 is a term. But down here in C, how many terms are there in C? I'm not going to answer that question for you right now. If there's an addition in the parentheses, but we know it can turn into this, right? Nick said the first thing I do is make my 8 plus 2 into 10. How many terms are there here? 1. Remember, things multiplied together are just 1 term. Interesting. Let's keep going on. Maybe we'll figure this out. This expression, 5 plus 3 times 4 plus 2, can be represented like this. Now, if you don't see it, please lock your eyes up here for a moment. This expression, 5, and then 3 plus 4, and then 2, right? Addition is and. So we have 5. And you're going to be asked to do this on your homework and on your mastery, so please, don't come to me and say, do I actually have to do? Yes. I rewrote your homework with the things I wanted to modify. If it says draw a diagram with pluses and minuses, yes, you are actually doing that. So please don't come ask me. The 3 times 4, 3 sets of 4, right? We show actually what it says. We don't just draw 12 pluses randomly. We show 3 sets of 4. And then 2 more. Any questions on how we do that? If we separate it by terms, 5 is a term, 3 times 4 is a term, and the 2 is a term. So then down here, we will not take very long. I wanted to make Monday an easy Monday. I know we're coming back from a long weekend and you guys are all kind of glazed over. So you don't even have to write this down. Just take a moment. How many terms are in that expression? Take a moment. Araya, you had your hand up earlier, but I never got to call on you. How many terms are there? Yeah, it's easier when it's right in front of you and you can actually draw or whatever. But the 4 times 5 is a term. The 1 is a term. The 3 times negative 2 is a term. And the 6 is a term. So there are 4 terms there. That doesn't mean that they're not like terms. Like, we can put all those together. We just have some math to do. But when we start, we have 4 terms. Any questions? Because we're whizzing through this and then we're going to be done real soon. So here, and I know it's on your paper because I didn't have space to squeeze it in there. We probably aren't even going to do
this actually, because a lot of these I would just tell you grab a calculator, right, and use that to help you with the math. Because and I read a lot of like education blogs and math teacher blogs. There's a shift kind of in the world of you don't need to spend your time doing something a computer can do for you really quickly. We want you spending your time on engaging your brain in the problem solving, not computation. Right, so we look up here and we just separate terms. This separates terms and that separates terms. So we have 1, 2, 3, right? And we move on to B. How many terms are here? Give me fingers. How many terms are here?
Oh yeah.
Not that. Give me how many you think it is? There are 2. Because remember, the only thing that separates terms are the plus or minus. This is not a minus. It's a negative. Remember, that doesn't separate anything. That's a negative. In C, give me fingers. How many terms are there? 1, 2, 3, 4. How many do you think?
2. Big max up.
2. Because the plus separates it. That's a negative, right? Negative 3/5. That's a multiplication. We only have 2 terms. Now, if we go through solving that, you don't have to write this down, but I want to make sure that we make this reminder about how this happens easily. Anytime we're working with a fraction, make everything a fraction because it makes your life easier. So if I make 5 a fraction, it's 5 over 1 times the negative 3 over 5. It doesn't matter where you put the negative. Give me your eyes real quick. I'm missing a few. That negative they show out front. But a lot of kids will accidentally, when you're doing your writing, all of a sudden the negative that is at the same height as the fraction bar merges together, and all of a sudden the negative's gone, right? Because when you look at it, the negative, put your negative above or below, it doesn't matter, but choose a location. I put it above pretty much always. What happens when we have a 5 on top and a 5 on bottom? What is 5 divided by 5? 1. So those reduce out to 1, and that becomes just negative 3. Then plus your 2 times 1.5, which, what's 2 times 1.5? 3. Oh, negative 3 and a positive 3? 0. The other reason we talk about identifying terms is it helps us follow the order of operations. Right? This term, we have something to do. This term, we have something to do. So here, how many terms? Give me fingers. Be careful, like take a moment. What do you think? How many terms? There are 4. Yeah, careful. Check those splits from addition. There's an addition. There's an addition. There's an addition. 3 additions makes 3 splits. So there's actually 4 terms. Right? 1, 2, 3, 4. That's a 1. Don't exactly know. We'll just do that. Any questions on identifying terms? Because here we would multiply. Here there's nothing to do. Here we would multiply, and here there's nothing to do. So it helps us look for what is there to do. And the last thing. What do we? Yeah, really. I told you, like easy Monday. You know, Garfield, whatever. What? Just so we don't have a day with no random cards. What do we do first? Oh no, my glasses in the pumpkin log. Because Molly's amazing and brought us pumpkin bread. What? Oh, Sarah's not here. Sarah, feel better if you watch the video. Callie, what do we do first there? Okay, well, she might be jet lagged. I don't know. She's in California?
Yeah.
What is she doing in California?
It was probably discovery.
I want to go. All right. Callie, what do we do first here? Hey, why are you talking to the person I'm asking to solve the problem? Callie, what do we do first here? We multiply first, right? Because those parentheses aren't doing anything. They're just grouping up the negative. So Bella, after we multiply, what do we get from that multiplication? Yeah, so start following. So this problem here, right, we're looking at that. If we split terms, we could split terms through the additions, and 1, 2, 3, we have 4 terms there. Callie told us to do the multiplication first. Once we do the multiplication, what do we now have? Like, what do we get from that multiplication? Yeah, 1 plus 6 plus 8, that's a weird 8, plus -4. I was already halfway through drawing a 6, okay? Don't judge. Now, it's kind of your choice, but preference, right? And I was tutoring somebody over the weekend that they didn't do this, and I was like, you're making their life too hard. Put your positives together, then deal with the negative. So 8 and 6, 14, 1 more 15, plus a -4, like minus a 4 is 11. And with that, work on your homework. Potentially. I have 2 things to talk to you about while you work on your homework. And a bunch of papers to pass back. The first thing, I'm going to leave the camera on for. If you know Eli Krause in 8th grade.
Oh, yeah. I don't know.
Oh, and what probably, is that Nikki's brother too? Are Eli and Nikki brother sister?
I don't know.
Wait, what? No.
I think it's
Nikki had a brother.
No shit.
No, Nikki has a brother.
She's older. She has a brother. She's not in this grade. Not in.
Alright, so one of our amazing Phoenix parents just bought us a game that I wanted to show you guys, and I'm going to have to make the punch-outs, like do all the punch-outs. But I can pretty easily show you on here. So this, you can be doing your homework right now. By the way, you can be ignoring me. This is the game board. Now, this is a game played with 2 people. The game is called Patchwork, and the point of it is to make a beautiful quilt on your grid space. Now, how you make your beautiful quilt is all of these quilt pieces will be spread out around the game board. So I got to punch these out. That's one of my favorite things with a new game is doing punch outs. But these game pieces have different sizes, right? This is a geometry game, essentially. You are trying to cover as much of your quilt as possible, like a puzzle. You're trying to put together a puzzle, essentially. However, the pieces that you're allowed to draw, you only have 3 options of what to draw. So real quick, if I can, I bet if I search. So let's say you're playing and your pieces are spread out like this around the game board, or this is probably a better picture. The pawn moves around the game board, and you can only pick from one of the 3 pieces ahead of the pawn. Then you move the pawn to where you just picked that piece, and the game continues forward. So if you are interested in patchwork, and if you know that you will get your homework done later, you may help me punch it out and then try to play it if you would like, or later, AO extensions, all those times. These games are going to live on the shelf in the library, so you guys just need to take care of stuff. Now, the other game that I don't really need to explain, you kind of learn it as you play it. But the other game that showed up over the weekend, don't know if any of you guys have ever played it, but it's called Star Realms, and that is also a 2-player game. It's a card game, and it's all based in space. So if you like space and lasers and like battle and things like that, Star Realms would be a game for you. So those are our 2 new games as of right now. Yeah, play them. They're fun. They involve math.